Okay, well, this is a quick example to show you a situation where you might need the quadratic formula to help you when you're doing work with kinematic equations. This has to do with motion under the influence of gravity that's coming from uneven heights. And we take a look at this. So a helicopter is rising at 5 meters per second. Package is let go at 30 meters, so the package will have the same velocity as the helicopter. But then gravity is going to start working on it, and we'll start taking away its positive velocity and then turning it around and bringing it back towards the ground. So a quick sketch of distance and time would look something like this. So here's y on the vertical axis, time down here, and we're looking for our package is going to go up a little bit and then come back down. Now, you could do fancy things like trying to break it in half and say that the velocity is 0 here, find this time, and then find that time. But it's a lot easier to just do this approach. So at least I think it is. And so we're going to take our list of variables and start filling it in. So initial height, final height, initial velocity in the y direction, final velocity and time. Fill them all in. And then here's our primary kinematic equation. This is a very special one. This is called the equation of motion. And it's going to predict wherever the object's going to be for any given value of time once we fill in the parameters of initial height, initial velocity, and gravity, of course. So filling them in, pretty straightforward, but obviously we're headed to quadratic formula town. So we need to rearrange this so it looks like the standard formula. And then it's time to go online and look at a solver. And so here's the one I typically use. Boop. Math is fun, and I'm going to type in the coefficients that I got. So 4.9 and 5, -5, and -30. And it is solved. So the two numbers are called the roots of the equation. Those are the values that are going to make the function equal 0. So again, they're called roots of an equation. You notice that we get a negative number. So what the heck is that all about? But well, anyway, let's deal with the positive number first. So that's the correct answer. And we'll go back and look at the document camera. So this time is equal to 3.04 seconds. Now, if so this is the one that makes sense in the physical world, but if we were to sort of plot out the early parts of this, then that's where the -2.2 would be. So keep this video in mind the next time you come across the quadratic formula. Have a great day.